So that's the sound of the compressor down there whining away at 5,000 or 6,000 RPMs because it's low on refrigerant, and the command is for cooling, but it can't cool because there's not enough refrigerant. As you can see from the sight glass right there, basically that's just all empty. Let's see if I could focus on it. Right there. So we're at 0 and 81. My last video cut out on me on video 2 because as I was trying to get you to compressor noise, my thumb hit the off button on the phone. No retakes. But I do have a temperature sensor down there. If you can see that yellow handle, see that right there? That's the temperature sensor off the pipe that comes out of the compressor. The temperature of the discharge of the compressor right now is just approaching 200 degrees. Now the outdoor ambient temperature right now is 66 degrees. That's one hell of a hot temperature for such a cold ambient temperature. So, and look at, now remember your PT chart? So why don't you go to the PT chart for R134 and look at 81 PSI and then cross-reference it over to Celsius or Fahrenheit. This is in Fahrenheit. And see what the temperature should be to equal 80 PSI. And you'll see that's super hot. That's now inside the compressor. You can add another 50 to 75 degrees at the right at the point of compression of the actual surface film temperature of the oil. The lubricant is approaching right into breakdown point on a cool day. Now imagine if it was 80 or 90 degrees and the customer just wants to turn on that AC and he goes, oh, if I could just get 1 degree cooling, because he feels air blowing over his hand and actually there's no cooling going on, but he thinks there is. So the customer will keep driving with that AC on, and this will go well over approaching 300 degrees on a 90-degree day if the customer keeps riding it like that. And this is how customers burn up their compressors, not knowing what's actually going on. And the computer will keep telling this compressor to go at 6,000 RPMs because it's trying to satisfy the demand, but the temperature sensor inside saying, hey, I'm not satisfied, I'm not approaching my temperature. So keep the RPMs up there higher, trying to move more refrigerant through the evaporator to cool it down to satisfy itself. It's a dumb machine. It doesn't know it's low. So it just keeps whining itself until it burns itself out to death. And that's how it works. We're almost 200 degrees. So we're going to do one more thing here. We are going to put some dye in the system, and I'm going to let you see how fast or how slow. When you're really low on refrigerant, it takes rather a long time for the dye to travel. And if you've seen my other videos when I take this, it only takes about 5 seconds on a full system. You put the dye right here, you fill up the system, you turn it on, and within 5 seconds, it goes from the low side suction port through the compressor, through all the parallel flow path of the condenser, through the receiver dryer, coming out the liquid line to come to this sight gas in less than 5 seconds. On a very low mass charge of refrigerant, and we're talking about mass. On a very low mass charge of refrigerant, it takes a little longer. Let's see. Okay, I'm hooked up. Let's get one of our black lights here. I'll turn on a black light so you can see the dye on my gauge fitting, but you can see the sight glass. There's nothing in the sight glass. So let's get this propped up in a way. I need a little Conroy light instead of this big giant mammoth thing that I use. Okay. Yeah, we'll see it come. Other than I have the light on here blind out. Okay, so I am going to pump in a squirt, and we're gonna see how long it takes. Okay, 1, 2, go. There we go. I just put in a squirt. And now we're counting. How many seconds does it take for the sight glass to glow? Come on. Come on, let's get a little glowing going on. Do you see how long this is taking? Come on. Give me some glow, guy. And I put another light on. I'm putting another light on there. So I got 2 lights. We're waiting for glow. It's taken a long, long time. A really long time. Okay, I think I see a little bit coming on there a little bit. You got a little bit of glow. Here it comes, it's coming more. You see how long that took? Now on a full system, it's less than 5 seconds. It's the mass of the refrigerant, not the pressure. It's how full the system is how rapidly the refrigerant. So there's very little mass moving around through the system right now because it's so low. And now it's fully green. So you can see the difference once it's really there. But this, like this, that's supposed to happen in 5 seconds or less on a full system. So now I'm gonna jump off to the next. I'm gonna look for the leak now. So I'm gonna cut this video out. We'll go into video number 4. And I have to wait for a buildup of a leak on the inside. I already have the Infracon D-Tech Stratus warmed up, and now I'll be searching inside. All right, guys, I'll see you. 0 over 80. It's like your blood pressure on a human being. You're dead.